And another way of solving a quadratic equation: if ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So find all real solutions of the equation using the square property, the quadratic equation. To use this, you need to get everything on one side 0 on the other side. So it is, then you read a, b, and c. A is 1, b is 3, and c is 2. So here x would be negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. X would equal a negative 3 plus or minus the square root of 9 minus 8 over 2. X would be a negative 3 plus or minus 1 over 2. Negative 3 plus 1 is negative 2 over 2, that's negative 1. And negative 3 minus 1 is negative 4, divided by 2 is a negative. Next problem up. I gotta make sure that I have 0 on one side, everything else on the other side. Since the problem says use this quadratic formula, you must use the quadratic formula even if it factors. X is going to equal negative b, b is 12 in this case, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. X would equal a negative 12 plus or minus the square root of 12 squared is 144 plus 4 times 3 is 12. 2 times 3 is 6, and this is a 6, 5, 1 over 6. X would equal negative 12 plus or minus, so 156. That's one flaw for using quadratic formula. You have to simplify the radical. 2 divides 15 7 times, you have 1 left over. 2 divides 16 8 times. That is 2. 2 divides 7 3 times. That's 6. So it's 4 times 39. 4 clears the radical as 2. Right? And I could factor a 2 out of the top. And that could cancel with that 3 times, and that would be my final answer. So, one catch for using the quadratic formula: you need to clean that radical. That's why I prefer completing the square over quadratic formula. Same deal happens here. I get everything on one side, 0 on the other side. And I would say x equal negative b, but b is a negative 2. So minus a negative 2 plus or minus the square root of negative 2 squared minus 4 times a times c, all over 2 times a. X would be the opposite of a negative 2 is a 2. Here I'm looking at 4 plus 16. That is the square root of 20. And we know the square root of 20 is 4 times 5, so 2 clears the radical. And again, I could factor a 2 out. And my answer will be 1 plus or minus radical 5. So it's a lot of work. I think completing the square is a lot faster and more efficient. But, you know, what do I know? That's my preference. Now, a different combination of equations come up here. Again, this is a review section, so they have all kinds of equations. Find all real solutions. Let's deal with these equations. Glancing at the first problem, it's a polynomial. We isolate the polynomial on one side, everything else on the other side. With polynomials, we know we need to factor. We take out 3x squared. I'll have x squared plus 6x plus 8. They want the real solutions. Well, 3x squared equals 0, which indicate x equals 0. Now, this factors into x plus 4 and then x plus 2. So x would be a 0, x would be a negative 4 or a negative 2. This is a radical equation. You solve a radical equation. So how do you solve an equation in math if you recall? You isolate the name by itself. When you say I have a radical equation, you isolate the radical on one side, everything else on the other side. In the first part A, I had a polynomial. I isolated the polynomial on one side, everything else on the other side. Here, I isolate the radical on one side, but it's already isolated. So how do you get rid of a square root? You square both sides. 2x minus 1 equal a 9, and you solve. And you should check your answer whenever you start the problem with an even index radical, a fraction, or a log. Visually, if I put a 5 there, 2 times 5 is 10, minus 1 is 9, square root of 9 equals 3, it checks. When I get to C, I isolate the radical by itself. It's already isolated. I square both sides to get rid of a square root. So that becomes x plus 5 equal, and here you FOIL. Now if I was to ask you what kind of an equation is that, you'd say that's a polynomial equation. How do you solve a polynomial equation? You get 0 on one side, everything else on the other side. You factor. And if you set each of those equal to 0, you get x to be a negative 4 or a negative 1. Now that you started the problem with an even index radical, you need to check negative 4. If you put a negative 4 there, negative 4 plus 5 is a 1. Square root of 1 is 1. Negative 4 plus 3 is a negative 1. 1 cannot equal negative 1. If you try the negative 1, negative 1 plus 5 is a 4. Square root of 4 is a 2. Negative 1 plus 3 is a 2. That one checks. So that's the only answer we have. Sometimes they both work, sometimes only one of them work, and sometimes none of them work. A couple of more examples. I see this again. D, I see a radical equation. I isolate a radical by itself. I get rid of a radical by square rooting both sides, by squaring both sides. And if I do that, what do I get? I'll get 8x plus 4. And here we need to FOIL. You get the first squared plus twice the product of those. 2 times 3 is 6. Plus the last square. If I was to ask you what kind of an equation is that, you would say that's a radical equation. So we'll isolate the radical by itself. Combine like terms. 9 plus 1 is a 10. Subtract 2x from both sides. Subtract 10x from both sides. Isolate the radical by itself. Divide by 6. Now that the radical is isolated, what do? You square both sides again. You FOIL. So if I move that over, that's x squared minus 4x. The ones cancel out. If I factor, so either x equals 0 or a 4. Does 0 work? Put a 0 there. You get 4, which is a 2. Put a 0 there, you get a 1. 2 equal 1 plus 2. That's not true. If you put a 4, 32, 36, that's a 6. If you put a 4, 8 plus 1 is 9, square root of 9 is 3, plus 3 equal a 6, that 4 checks. So visually you could check if you start the problem with a fraction or an even index radical. Here, I know it doesn't look like it, but this is quadratic. That is, if you square this, so if you let y equal x to the 2/3, if you square both sides, when you square this, you multiply the powers, that's x to the 4/3. So this is like saying y squared minus 3y minus 4 equals 0. This factors y minus 4 into y minus 3 equals 0. 1. There. So either y equal 4 or y equal negative 1. Y equal 4, remember that's what y equals. So y equal 4 indicate that x to the 3/2, that's really what that is, equal a 4. You cube both sides, and you square both sides. And if I take y equal a negative 1, that means cube root of x squared equal a negative 1. You cube both sides, and x squared can never be a negative 1. And that would be my final answer. And the next set of problems, I see a fraction. I go for LCD. The LCD is x plus 2 times 4. Well, what is this missing? This is missing a 4. This is missing an x plus 2. And this is missing a 4. So since it's an equation, I read the top. That says 4x minus 12 plus x times, I'll write that in 2 steps. There it is. This is 4x minus 12, x squared plus 2x, 4x plus 4, combine like terms. And what kind of an equation is this? This is a polynomial. Get everything on one side, subtract 4x from both sides, subtract 4 from both sides. This doesn't factor. I prefer completing the square. So I move the 16 over, take half of the middle number, which is 1, and square it. This becomes, of course, you're welcome to use quadratic formula, but at least here I don't have to clean the radical. It's already clean. That's always happens, almost most of the time. So x will equal a negative 1 plus or minus the square root of 17. And if I look at the last example of these types, this is x into x minus 4. The LCD is x into x minus 4. This is missing nothing. This is missing both, so you multiply top and bottom by x into x minus 4. And this is missing an x. You multiply by x. It's an equation. You ignore the denominator. So this reads 3x squared minus 12x plus 48 equals a 12. This is a quadratic equation. Get everything on one side, 0 on the other side. Divide by 3 both sides. Factor. Nope. So x minus 4 equals 0, which means x equals a 4. But do you notice if I plug the 4 in there, that will give me a 0 in the denominator? Since that's the only solution and I can't have it, this equation has no solution. So either you write no solution, or you write the empty set indicating there's no solution. Anytime there's no solution, you must say no solution or draw the empty set equation. Absolute value. If the absolute value equal a number, then whatever's inside the absolute value equal that A or negative that A. Remember, absolute value is always positive. The key is again to isolate the absolute value by itself first. So glancing at this, I have an absolute value equal 3. So either I'm going to say, as I see this, x plus 2 equal a 3, or x plus 2 equal a negative 3. And I solve each linear equation, subtract 2 from both sides, subtract 3 from both sides, and there it is. That's simple. Absolute value equaling a negative, there's no way that could happen. An absolute value is always positive. There's no way a positive value will ever equal negative. And what if I have a variable? Well, it's the same thing, same process. According to the absolute value, one time you write it without the absolute value. Or x plus 3 equal negative 2x. Well, here, if I solve for x, subtract x from both sides. Here, subtract 3 from both sides. Now, if I throw the 3 in, 3 plus 3 is 6. Square root of 6 equals 6, that's right. Negative 1, 2 equal negative 2, that doesn't work. We normally don't check absolute value, but whenever you have a variable, you gotta be careful because you want to make sure that the variable is never negative, even though domain doesn't apply. Well, last two problems. If I want to solve for r squared and I only see one r, I isolate r by itself. And to get rid of a square, I use the square root property. R equal plus or minus. Now, isn't that radical a over radical pi? So if I rationalize, multiply by radical pi top and bottom, that would be my answer. Part B is a bit of a challenge. I want to solve for x. I would compute the square. S plus a number equal x squared plus 4hx plus a number. Keep in mind in this case, the challenge, there's x. That's a 1, so that's good. I can complete the square. The number in front of x is 4h. When I say take half of the middle number, that's half of 4h, which is 2h. And when you square it, that's 4h squared. I'm guaranteed that this becomes a perfect square. X with that sign, the number before I squared it. And if I square root both sides, I will get the square root of s plus 4h squared equals x plus 2h plus or minus. Move that over, and x will equal negative 2h plus or minus the square root of s plus 4h squared. And that would